podcast of December 4th, 2018. I'm Tom.
And I'm Stefan. And today we're going to talk about a recently proposed method from Adrian Boyer, who talks about how you could reinforce your 3D prints with virtual fibers. And we're also going to talk about different slicers that you can use for 3D printing.
Yeah, and as always, we're also going to we're going to answer some of your questions from the YouTube comments that you can send to us there or on @the_Meltzone on Twitter. And before we get into all of that, let's actually talk about what we've been up to. Current projects is the headline here.
Yeah, and we have briefly talked about that before, and I think current projects are pretty IT related. So you have been complaining that you get some software issues, and well, my things are more on the hardware side. So what have you been up to?
Yeah, you know those problems in Adobe Premiere, as we all do, where you have crashes and random stuff just not working the way you want it. And there's nothing you can do about it. That's the frustrating bit about that. That's what my life has been for the last few days. But it's not... I don't know why I keep using Adobe Premiere. It's come to haunt me so many times, and you know it's a monthly subscription. I keep paying for that software, and every time a new update comes around, it just stops working for a month or two.
Yeah, but the thing is, you're just so used to working with that software that switching to another one would be that much effort that there really needs to be a good reason that you do a change.
Yeah, but the question is, like, how much time will I spend once to actually learn something like DaVinci Resolve versus having to deal with all the crap that Adobe is throwing at us every year? So I don't know. I'm definitely looking into other alternatives. If you guys watching or listening have suggestions on what I could switch to, that is not Final Cut, then I'd be very welcome for that. Leave a comment below. And Stefan, you've also been, I guess, upgrading for Adobe.
Yes, I've been upgrading for Adobe. So, well, when I started my YouTube career, I used to render my first videos on my old Ultrabook, which had an i7, the mobile version, and was fine for the first couple of 2 or 3 videos. But then I just got really, really upset with the rendering times. And just like 2 years ago, I bought myself a gaming notebook, a Razer Blade gaming notebook, which is really, really powerful and really expensive.
Yeah, and the interesting thing, like gaming requirements and video editing requirements are so closely matched, except for maybe RAM. You need a bit more for video editing, but everything else is pretty much the same. So you're getting the gaming notebook, and it's great for editing too.
Yes, and so. Well, before I used to travel with my laptop a lot because, I used to do my master's. My girlfriend was living in another town. So I really liked to have a small machine which was powerful, so where I could work on, but is still portable. So I decided to buy a Razer Blade, and I was quite happy with that machine for the last 2 years. But the thing is, it's a fast machine, but when you really use it, it gets so loud. So during rendering and during working, you kind of always have to wear headphones. And this was bothering me quite a bit. So I just thought, okay, it's Black Friday. Let's maybe invest in a new workstation. Because before, I always used to work on normal PCs. I gamed a lot. I had water cooling in my old machines and all of that. But just, a couple of years ago, I dumped that machine, didn't use it for 3 years. So, now I finally bought myself a new workstation, which, features a Ryzen 7, a RTX 2070 graphics card, 32 gigs of RAM. It's a really nice machine. It's quiet also during work. I haven't been doing any editing so far because just normal work is keeping me that busy, but that'll come at the weekend.
Well, let's just say it how it is. You've been gaming on it, right? I bet.
No?
Oh, come on.
Yes, of course I did. I was playing quite a bit of Battlefield 5 at the weekend, and I noticed that I still suck at it.
Yeah, that's the Battlefield experience.
Well, yeah, I used to play PUBG quite a bit, like half a year ago or a year ago, and I always thought maybe I suck that much because my machine is not perfect for that. No, I have a new machine and I still suck at first-person shooters. It's a lot of fun. I'm not the worst, but I would prefer if I would be better. Well, yeah. So yeah, I have been gaming a
Wouldn't
bit.
we all?
I have been gaming a bit, but I'm really looking forward to creating the next video on the new workstation.
Yeah.
It's just to see how it works out,
Yeah,
especially rendering the podcast, which is a really long 1080p video. Took ages on my old machine.
Yeah,
It was like
it's not in 4K or anything. It's just a 1080p 60 video, so it's like not the most strenuous part. But I saw in your specs, like you went for solid choice. You went for the Ryzen 7 8-core, but you didn't
2600X.
Yeah, the 2600. You didn't go for Threadripper, which is like the logical thing. I have the Threadripper. I'm very happy with it. Why not though? There's not that much of a price gap, right? Well, there is.
There is a bit of a price gap.
You've got the 2070 in there, so that.
Yeah, it wasn't a cheap CPU to start with. One of the reasons why I didn't choose Threadripper was just the energy consumption. I don't know. I'm just always looking at my machines that I use quite for a bit of time don't draw too much power from the wall. You have the great advantage that you're using green power, that you harness yourself from the sun, but I have to pay actually my not in the winter, and that since it's raining for the last couple of days. But the Threadripper has a TDP of almost like 200 watts.
So the smaller ones, the smaller 16 and 12 cores, I don't know if they don't make the 12 core anymore, right? With the second generation, but it's 180 watts, and then the 32 core is up to 250 watts. So that's just TDP, right? That's not idle.
Yeah, you need
lower.
A gigantic heatsink, better, probably a water cooler.
The bundled one is even a water cooler, yeah.
And that just was, drawing me off. At the moment, I don't do any 4K editing. I don't know if I'll get to that and regret that choice in the future. I still think it's still a decent choice for a rig that you can use for editing and some casual gaming from time to time. You don't have an electric...
Says the guy with the RTX 2070 and the Ryzen 7. Sure,
well,
casual.
You need to have ray tracing nowadays. Didn't see any difference in Battlefield, though. So I switched it off again.
Hype. Hype is real.
The 2700 was like $100 more expensive than the 1070.
Oh yeah, that's a good deal. Because it's way more powerful.
Yeah, it's way more powerful. So for this reason, I just thought, screw it. I'll buy the RTX, and maybe there will be some really nice content out that I can use ray tracing. Where you can use it for ray tracing.
Yeah, maybe there's going to be some application in wherever. Maybe Fusion 360 is going to support it at some point.
Well, I'm not really the rendering guy in Fusion 360, but it has potentials. I don't know. Yeah. Well, I think currently it's for selling new GPUs because they are not like massively faster than the older generations. It's just like with new cars, new skiing equipment, new bikes, you always need to have something new because otherwise people are quite happy with the old stuff they're having.
Yeah, and I mean, you need to keep the economy going somehow, right?
Yes, definitely, and that's exactly what I did. It's a really nice machine.
For sure. And I mean, looking at what resources are being used on my system, which is kind of equivalent, but with a 16-core Threadripper, the CPU usually isn't the bottleneck.
Nope.
So you should be, and I'm editing 4K 60, so you should be fine.
Yes,
for sure.
I should really compare rendering times between my old system and the new one, just to maybe be even more happy with the choice I made.
Yeah, I actually did some benchmarks on just a benchmark project between when I got this laptop, which is the Huawei MateBook X Pro dedicated GPU. That's the only reason I got it. Between this, a 2-year-old mid-tier gaming laptop, and all sorts of other things, and this thing is actually doing pretty well. It's taking like 4 times as long as the desktop. Yes, sure, but on a scale on other laptops, it's holding up pretty darn well.
Yeah.
So yeah, yeah. Well, the thing with editing hardware is like you can pretty much edit on anything, but it's just going to take you long. It's going to be slower. And with proxy workflows, like we've discussed, the same thing I do with my editor from Norway, we just send back and forth proxy files, or I send in proxy files. So there's not a lot of data and a lot of processing that needs to happen. If any one of you listening wants to get into YouTubing and making videos, just start with what you have, because most of the stuff you have can handle it. It's just it might take a bit longer than fancy hardware.
Yeah, definitely. And also just the workflow in Adobe Premiere usually is quite fast if you're not doing 4K on a like $200 laptop or something like that. So
Yeah,
it's fine. But it's just like comfort for me, and well, it was kind of a nice feeling to buy a new machine. So
oh yeah,
I just went for that. And I haven't been building my own system for the last 7 or 8 years, because for the last time I've always been purchasing laptops because I was doing my bachelor's, doing my master's, and I needed to have something portable. But now that I'm like having a normal job and don't travel a lot with the equipment I own myself, a workstation for me is the better choice. And I still have a tablet that I can use on the sofas and something like that.
So you're completely getting rid of your laptop.
Well, I will definitely keep one of them, because I also use my laptops when I'm CNCing.
Right.
But I'm really thinking about selling my Razer Blade, because this was an expensive laptop, and it's kind of hard keeping that around and knowing that you like use it like 2 or 3 times a month.
Yeah.
And it's maybe still worth like $1,000. I don't know. I need to get my head around that.
Yeah, yeah, and you mentioned you've. I had such a good transition planned out, but don't think I'm going to be able to make it work. You mentioned you've got a more like regular job situation now, and you're working as a simulation engineer.
I used to work as a simulation engineer. I am, well, a 3D printing research engineer. With some minor tasks in simulation and optimization. Perfect transition.
Yeah,
and this is the reason I was really hooked by the Twitter post that Adrian Boyer just made like a couple of days ago, and it has been on a lot of news site the last recent days. And this was the making your 3D print stronger with the virtual fibers.
Yes,
you put into your part, and the idea behind that is not a new one, but just the way he showed it is a pretty nice thing, and it's just thinking a little bit out of the box. So basically, he's saying that use finite element analysis to find the areas which are highly stressed into your part. And this is the interesting thing. Add voids into your material at the locations where you have high stresses. And what that is causing is that you will have top and bottom layers and additional perimeters in the region of, in the highly stressed regions, and therefore stiffening and strengthening your part. And this is something totally cool. There is not something which is implemented in any real commercial software yet, but I see that this might be something which could be something that maybe Fusion 360 might be adding, because they have this big repertoire of all CAD CAM software, and
and they do have a prepare for 3D print kind of function.
And well, FDM 3D printing, even though it is not the most, I would say, professional 3D printing method, still is used in quite a lot of commercial projects. I just had a guy at work today who showed us some scanners, and all of the parts for holding that scanner and everything was all 3D printed, all FDM 3D printing.
Yeah. Sure.
Because it's way cheaper than making an injection mold.
Yeah.
And if you're not doing like 100 parts, or well, if you're not doing like 10,000 parts, it's often just not worth it. I don't know if they will be changing in the future to injection molded parts. It didn't look that professional, I gotta be honest there. But still, if you have this method that Adrian Boyer was showing, if it is implemented in nice software packages, it can be used in the future to strengthen parts that are mechanically stressed automatically and in a really cool manner.
Yeah. So I guess let's take a quick step back and actually look at what's kind of happening in the process. So you start with a part. Let's say if I had something that I could demonstrate this on, let's say this Vive controller, and you figured out, okay, this part up here where kind of the sensor ring meets. Sorry, that probably blew up someone's headphones. I'll edit that out. Let's say this part where it meets the handle to the sensor ring is something that is structurally stressed because people bang it against the walls, which I've done on this one many times. And you figure out, okay, we need to reinforce like this portion. So what they are suggesting is to actually add small holes. So we've got a picture here that looks like someone's been drilling randomly oriented 0.5 millimeter holes into a cube, basically, and looks like a fiber reinforced bit. And what then happens, because those holes are in the part, the slicer, which is also something we're going to talk about later, slicers, then sees that hole and is like, oh, this is a shell. I should create some perimeters around it. I should create some top and bottom solid layers. So it actually adds more material where each of those little, holes and channels are in the part. And that in turn strengthens your part because you have a kind of directional fiber, I guess, even in your part. Now, of course, this is something that is very specific to FDM 3D printing. It doesn't work in SLA, SLS. It doesn't work in subtractive manufacturing, because if you take a part and drill holes into it, like it's not going to get stronger. It's going to get weaker, right? And
yeah, but with FDM printing, where your part internally is hollow, you only have the infill.
Yes.
Adding or using this method will create more materials in the regions where, you want to have more. And again, this is not something new. This has been used. I think Prusa was posting something in an old...
It's been around for a long while.
Yeah. Slick 3R has also a feature where you can add modifier parts to your 3D printed part, where you could, for example, change the infill density in specific regions.
Yeah, so it's a second STL you load in, and wherever that STL intersects with your original part, you can say, okay, that area is going to have more or less infill. So I guess that would be similar to the suggested fibers there. And I've asked Adrian on Twitter, like, hey, what's the... because when you first look at that image of that cube with just random fibers oriented in it, and it's like, yeah, okay, well, that's infill, right? That's exactly what infill is for. I was like, hey, why can we not just use infill? And the specific thing is, those fibers in the part are actually just a means to communicate from your CAD package into the slicer. Okay, I want more material here. I think we could achieve pretty similar results if we just had a second modifier mesh and imported that into the slicer and just said, okay, we want more infill here. The critical part is not the fibers themselves, though they're nice because you can orient them like fibers. It's actually that the part where it can have varying material deposition densities, infill rates essentially, right? In your part that can be determined by simulation or empirically or however you want.
I actually totally forgot that. I actually used the same method on my test hooks, because I had the problem that if I was using really elastic material like nylons, for example, the hook would bend at a specific region too much that I could not load it enough. So I added a really small slot on the inside to add additional material there. It's totally neat. The thing which was bothering me a little is that the article is named "Making RepRap Prints Stronger Without Doing a Lot of Work." Yeah, in theory, but I think at the moment it is kind of a hassle to do, because especially with the suggested workflow that he proposed, it's you do a finite element analysis, you take the results from the finite element analysis and add CAD geometry in the regions where it is highly stressed. Then you export that part and all of that. At the moment, since it's not implemented in any commercial software packages, it is still a lot of work. But as I said in the beginning, I could see that being implemented in software tools like Fusion 360 CAD packages. Yeah. And since finite element analysis, especially linear finite element analysis, is not something really complicated, I could even see things like these being implemented in slicers. It would be a really big module added to it, but the code behind that is not that complicated. I think the interesting thing will be, how do you interpret the finite element results into CAD geometry that will then be these virtual fibers? This is the challenging part.
I almost feel like it would be easier to have that modifier mesh as an extra output, as an additional piece of geometry that it can just load into your slicer, because that's not going to have like the fibers needing to be defined somehow directionality wise and pattern wise. Though again, we could probably make that work. What was I going to say? The thing with simulations, at least in my experience, is always it's more work to actually just set up the simulation. Because I mean the processing time you need is trivial, and then setting up your simulation in the first place and actually getting it right and getting it to the point where it makes sense, where you're not just simulating something in a vacuum that has no relation to your real work loads, real life work loads. That's the challenging part, and I think we're going to need a bit of education on that topic first before we can dive.
Yeah,
English is a hard language. Yeah, before we can get into that sort of topic for everyone. That's just my point of view. Just make simulation a bit less mystified and more approachable.
Well, I think simulation is pretty approachable in, for example, Fusion 360 and other finite element packages. But I think, from my experience, this is the dangerous part, because everyone with the really stupidest assumption can make pretty pictures.
Yeah.
And he gets a result. If these results are feasible, that's a totally different question. So I don't think this is something maybe which everyone can do or everyone should do in the future, but people who have knowledge and kind of experience in that direction can use this method to make their FDM 3D printed parts even stronger than they used to be before.
Yeah. Here's a question I still have though. Do we already have a way of simulating 3D printed parts that aren't just a solid? Because when you simulate something that is machined, you assume it's a solid aluminum block.
Yep.
But with a 3D print, you have your shell and your infill, and you have stuff like layer adhesion that is, non-isotropical material in the end, which we can simulate. But can we simulate infill?
Yes, there are. How do you say in English? So there are ways to do that. You could just, for example, like omit the infill and say, okay, the infill is not adding any strength to the part, so you can just simulate a hollow part, which is for some parts quite a good assumption. But I don't think it's already implemented in commercial software, but I have seen that in papers that people used the G code to read the direction of the filament strands that are put onto your part, and then map this information to the elements in your finite element simulation model.
Okay,
And
so that
because
wouldn't
then
add geometry, that would just add information.
it only adds information. And I think this is probably the way to go, because it's still fine if you just use PLA or non-filled materials, because these are, at least from in terms of stiffness, kind of isotropic, and that is the thing which is interesting for you if you do the finite element analysis in the first place. But if you are, for example, take a look at fiber reinforced materials, their stiffness is hugely dependent on the printing direction. You've been using the Markforged printer.
Yes.
There it is even well, a bigger advantage, disadvantage, however you want to put that. But simulating these parts is really challenging, and you need to have methods that can automatically map the information on the CAD part or on your finite element analysis, and then get feasible results out in the end. But this is still something which is not really implemented in any standard finite element tool, as far as I know it.
I guess what we could do, just as an approximation for now, instead of just leaving out the infill and assuming a shell, replacing that inner material with something with a second material that is, not as stiff and not as strong as your shell, but percentually less.
Yeah. This is, we do. Yeah. I also did that. This is homogenization of the infill structure to just the specific directional dependent material values, and then you don't really model like the infill itself, but you homogenize it into just one big mass, which has lower properties than if it would be 100% infill.
Exactly.
Yeah.
And I guess that would be something that could be fairly easily implemented into Fusion. If you have some preprocessor for your simulation workflow, just go, hey, this is a 3D print, shell thickness, infill ratio, boom.
Yeah.
Rough approximation. Right? It's not going to be perfect. It's going to be roughly there.
Yeah. In the end, it's finite element simulation. Even though it's easy to set up models, it needs some experience, because otherwise you're just creating pretty pictures without any sense behind them. It can be done at the moment, but it's just not as straightforward as maybe some are or would like to have it. But if you take a look at more professional 3D printing, like metal 3D printing, at least powder bed metal 3D printing, the material properties are kind of isotropic in terms of stiffness. So simulating these parts is and you have a solid. There, the isotropy, anisotropy is more in terms of the strength of the part, because you have different strength values, perpendicular to your layers, or like in the layer itself. And this is the challenging part at the moment.
Yeah.
But there's lots of research going on. So if you are a student, there are lots of projects at the moment going on in that direction, because this is something where still research can be done. Not everything is totally finished at the moment. So it's a really interesting, research area to work in.
Right. I mean, we have. The way I think we are kind of in the progress stage of this is we can do many things, but it's just not approachable or not usable. It's not implemented anywhere. So I don't know, creating methods that people can actually use in their workflow is going to be the bigger challenge, right?
Mm. Yeah.
Sweet.
So we have already been talking about slicers there,
yes,
where you could already use something similar there with the mesh modifiers. So that is probably a nice transition into the area.
We're just rolling on nice transitions today.
Yeah, we are totally rolling there. Which slicers we prefer to use. And you've been just telling me that you have only been using like Simplify 3D for 2-3 times. So
yeah, it feels like that for sure. I mean, that they gave me a license 2 years ago or so when version 3 or something came out. I don't know. Like, hey, we're releasing this new thing, and here's a license if you want to cover it. And I was like, sure, I'll check it out. Of course, Simplify 3D has this entire Pandora's box attached to it, I guess, because it's a commercial product. It's the only commercial, well, not quite, but it's the only popular commercial slicer that people actually use. So, well, they used to be NetFab, which was also the slicer at least was commercial and licensed for the first Ultimakers. But that's kind of gone away. Yeah, Simplify 3D. What else is out there? Simplify 3D, Slick 3R, Cura, Kiss Slicer, Craftware, Skyforge.
And lots of the just proprietary slicers that are used for the Sortrex printers.
Yeah, but do you actually think those are like proprietary their developments, where it's just Cura
well, they
with
have their own graphical user interface.
Yes. Yeah, I mean, MakerBot slicer, obviously, stuff like that, yes. But many of the small manufacturers, I feel it's just like it's the engine from somewhere.
But I guess the most popular ones are Simplify 3D, Slick 3R or Slicer or however you want to call it, and Cura. I guess they are probably covering like 80-90% of the non-professional slicer market.
Yeah, for sure. If it's not even more than that. So, I mean, my personal slicer of choice is Slick 3R, which I like because it's like super easy to set up, and it just, it gets you the results you want. I know how to turn all the knobs in there, and it's been getting so much more powerful since Prusa kind of branched their own version off of it. So I really like that. I also like Cura for, Cura feels more streamlined and I guess more professional. Well, I guess you just have to look at the user interface and you'd get that idea as well. But Cura is also really nice because you can tweak so many more things than in Slick 3R, and you can really set it up for dual extrusion, and it does some really nice things there. So for the Ultimaker 3, it's a perfect match. But I've also made it work on other printers. And then on the other hand, Simplify 3D, I go in there and I'm like, okay, why would I want to use this? This is so much harder to use and so much more complicated, and stuff is scattered everywhere. And I don't even know where the button to print is.
Yeah.
So I don't know. What are your experiences with Simplify 3D?
Well, when I purchased my first 3D printer, so my Mendel 90, I was using Slick 3R at that point, and this was still the version that Alessandro Ranelucci still was developing at that moment, and it was kind of hard for me in the first place to just find all the knobs and tweak everything. The thing which you really like about that, and I also now really like about Slick 3R, having worked with it for quite a while. But the thing that was always bothering me was the really old graphical user interface, and also the support capability. And this is, in my opinion, one of the two features that is still standing out with Simplify 3D at the moment. And this is the great supports that they're making, and the possibility to modify the supports in a really easy way that you can tweak them and only have supports in the areas where you need it. And this is one of the two reasons I'm still using it for complicated models, because I have the full control.
Yeah. So you're saying you're still using it, as in you wouldn't be using it if it didn't have those features?
I wouldn't be using it if it wouldn't have this feature and the processes. These
Okay.
are the things that are really important for myself. So because the processes I use is for all of the testing I do with my printer, because I want to set up one print which is where all of the parts have a different parameter applied to them, be it temperature, be it speeds, be it whatever you could tweak.
Yeah.
Yes, this is also possible in Cura. It's also possible
Sure.
in Cura. It's possible.
Okay.
You can apply different parameters to different models. It's not that
Oh.
easy and not that nicely shown and everything at the end, like in Simplify 3D. But it can be but it can be done. But the thing is, this software is like $150, and at that point, when I purchased it, it was really worth the money because it was the only software that could do that. It was creating really nice G code. The G code preview is great in Simplify 3D, but during the last like 2 years, more or less, no development has been happening, and this is upsetting quite a lot of people. Not only me. I also purchased it with my own money at that point. And it's starting to lag behind. It's starting to lag behind on features. The new version is totally buggy, and not a lot of is happening. And this is kind of upsetting me.
Yeah. I mean, I would agree with you on the simplified 3D features there, for sure. Like the custom supports. I mean, usually when I design stuff, I design it so that it's 3D printable, so that I don't need to worry about adding supports later. But yeah, it would have come in pretty handy at some points. The processes, yeah, it's something that the simplified 3D, I guess, makes simple. As the one thing that it actually makes simple, you can slice G codes, right, on from other slices. You can just manually copy paste them together, and you get like a plate of parts that prints in sequence, and every part is printed differently.
But it's a manual step, and I guess there are
manual step, yes.
Not a lot of people around who do that, and these are really the
What I've also seen processes used for is adding, for example, different infill percentages over the print of a part, which is again something that I love about Cura, because it gives you that option of having, for example, staggered infill. So you have, let's say I've worked with a company that I've probably pointed out before, but printing large parts for pumps that then get burnt out and used for investment casting. So you don't need a ton of infill in there. You have a top layer that is densely supported, and then the further you go into the part, the infill just gets sparser and sparser. And that's just nice.
That's really great.
It you set up one profile and it does it for you.
Cura is also nice because there is lots of development happening there, because Ultimaker is using that for their own printers.
Yeah.
And they are so nice that they are also giving it away for free to be used on any other machines.
Yeah. Was Cura always part of Ultimaker, or did that?
I don't know the history there.
I think they hired the Cura developer, but the main developer. But don't quote me on that. And it's the same thing as with Slicer, Slick3R, that Prusa is basically made their own now. Though I gotta say, the Prusa Slick3R and the Slick3R, the regular mainline Slick3R, they're both being developed. Just over the last few years, the Prusa Slick3R has been way more visibly advancing, whereas the version from Alessandro, didn't have an official stable release for quite a while. And just these last few weeks, I think they've had a new major release coming out. They've had beta and testing builds basically happening for a long while, and very regularly. But just now they've actually had a full release again.
Really?
Yeah. So it's not that it's the Slick3R project, the mainline Slick3R project is not that. It's still being developed. And I mean, I can see it drifting apart in features from the Prusa fork, as obviously a software does when you have two completely independent developer teams. I guess they are being inspired by each other's improvements, but at this point, they aren't really compatible to each other anymore. because Prusa's done a ton of rework on the Slick3r code base, and you can tell. You open up Slick3r, you drop a model in, and it's basically instantly sliced now. Which used to be a big advantage of Simplify 3D, right? Slicing speed.
Yeah.
Because it was the only software that was actually compiled. All the other ones were just being interpreted from Python or Perl in Slick3r. So yeah, that's been happening. Now
I don't know if also, so more or less all of the Chinese printer are bundling Cura version 15.07 or something like that with their printers. I think this is also something which you are looking a little bit confused.
No, I'm looking at my audition recording here because I'm noticing my levels are way lower ever since I banged the microphone. I'm not sure if it broke something in here.
Well, if it's the recording, it should be fine. No, I guess more or less all Chinese printers, Creality, Tron XY, whoever are shipping Cura or some kind of a version of Cura with their printers. So Cura is a really popular tool with lots of 3D printer users because this is the tool they got with their printer. It's kind of nice to use. So yeah, I guess this is also one of the reasons why it is that popular at the moment, because it's shipped with every printer. Everyone more or less knows how to use it. I don't really know why lots of manufacturers, or at least a year ago, still shipped a really, really old version of Cura with their
Cura
printers.
15.04 is like, I don't know, Cura wasn't that good back then.
No, it wasn't.
But that's something that I think we can say about pretty much all open source slicers, is they've massively progressed over the last, I don't know, 2 years or so. They have been getting so much better. And a lot of that stems from just having better presets and better kind of automatic guessing mechanisms in there. Because you could even get I'm probably leaning out of the window pretty far here, but you could get a print that looks pretty much as good as, anything that is sliced with a modern slicer out of even the old SkyForge, if you tuned it in properly. Stefan, I don't think you've ever used SkyForge.
I've never been using SkyForge, no.
Yeah, so you probably also don't know how Slick3r started out. Because it's not always been this massive complex software that is today. Back in my days, we used to have SkyForge, which was a Python, I believe, software package that took about 2 hours to slice every part, which was good fun. It was incredibly slow to use. It had incredibly weird and interlinked parameters, and then at some point, Slick3r came along with like 3 settings you could change, and it would automatically guess the rest. And people are like, dude, yeah, sure, I'm going to use that for the rest of my life. So it really was a disruption in that sense, that something new came along and it radically changed the way we were using slicers. Because tuning in SkyForge was its own kind of science. Well, it was probably more of an art than it was a science, and then something new came along. And when Simplify 3D came along and people started using that, I'm not sure if it actually improved much as far as like print results were over what people were using, or if it was just that the defaults were better guesses than what your software was that you were using before. Yeah, I guess one more thing that I kind of just want to get out there with Simplify 3D. I think they have a 2-week trial now, free trial or a refund period or something.
Yeah, it used to be a refund period, and this was drawing lots of people off using it.
Yeah, and I had asked them about, hey, can you provide like a demo or something before they sent me a full license, but I think that also kind of played into the hands of Simplify 3D, because it was this mystical, this kind of ominous software you'd download, you'd buy, and then all of a sudden your prints would be so much nicer than what you were having before. It's like this magic bullet, right? and people out there that didn't spend the money on it couldn't verify it. And there is a thing that is called, I actually noted it down, confirmation bias. Yes, the opposite of buyer's remorse. So you buy something and your brain intuitively wants you to kind of be happy with your decision, because you don't really want to like tell yourself, oh yeah, I've screwed up and this isn't actually better. So I think that also kind of played into it. But now that more people are using it, we can make some more unbiased comparisons, I guess.
But yeah, definitely. Maybe staying on the topic, I think the question which is on the mind of lots of people around there, is there still a huge difference in terms of print results if you're using Slick 3R, Simplify 3D, or Cura? I don't know. How do you usually tune in your printer? Because like printing profiles is something that is shared on internet forums and something like that. And I don't know if it's really still that necessary at the point we are today. Because quite honestly, how I tune in my printers, I see if there is a profile available sometimes in Cura. Otherwise, I just use anything and change bed size and retraction settings, and it usually prints fine. So exactly. I think there is not really that much magic involved there anymore.
I mean that there is some tuning potential for stuff like temperatures, sure, because the thermistor is going to read differently. For retractions, if you're using a Bowden or a non-Bowden setup, that sort of thing. Maybe yes, if you want to get rid of ringing, you tune your accelerations and jerk settings. But really, yeah, it's the same for me. If I get a new printer and I want to print something, I just open up Slick Through. Bed size, nozzle size, filament diameter, and usually it's going to print actually pretty darn well.
Yeah, and the thing is, if you really want to have nice prints, lower your printing speed and lower your accelerations, and you'll get the greatest prints that are out there.
Yeah. Now, one of the things that I've noticed about Simplify 3D, I'm not sure if they're still doing it, but if you create a new profile in Simplify 3D and just set something up from scratch, basically, and I've also noticed it on many of the pre-configured profiles, is their extrusion multiplier is actually set to 90%.
Yes.
And it's like, yeah, sure. I mean, that's going to make your prints look fabulous, but you're going to... it's just wrong. Sorry.
I have seen that so many times, and people were saying, oh yeah, I get the greatest print results if I use that small extrusion factor. Yeah, your prints look nice. They're not over extruded. But they are just weak on the inside. The perimeters do not adhere properly to another, and all of that. It is something which makes more or less every printer work, and you can print really nice like cats with it and whatever. So the standard prints, decorations, but it's not really usable for. Well, it is not optimal if you have stress parts. Then you should really try to tune in your extrusion factor.
Yes, sure. And I always, typically I get a printer and they're usually tuned in for like 3 to 5% under extrusion, just from the, you do 100% in your slice. So you usually get a bit less material than you think you are from your printer. And I think that might also be kind of a hack on the manufacturer's side, where they're just, trying to get their printer to print nicer, because people look at like how something looks. That is very easy to assess versus, how strong is it? And we've even been struggling with, actually assessing in a comparable fashion how strong prints come out. So yeah, I mean, if you're happy with that, just lower your extrusion multiplier to 90% in any slice and you're going to get way nicer prints.
Yeah, well, this is the point. Under extrusion usually doesn't look that bad. You will see it on your top and bottom layers that they're not totally filled. But it's usually fine. Over extrusion is the problem, where you get, the top layers don't look nice. The side layers might be too squished down and everything. Yes. Details don't look nice, and all of that, which is in there. So if you want to have nice prints, 90% might be fine. Maybe you could even go a little bit higher, but it is not optimal. And it is like a bit of a workaround getting more or less any printer to good print results.
Yeah. And I guess as closing thoughts for slices in general, like I think that you can get really good prints with basically any slicer today. I have noticed that there are specific areas where some slices are better than others, and some artifacts that you see with some slicing engines that others don't have. For example, I've used Kiss Slicer with the Monoprice Delta Pro because that is their default slicer. That's what they ship with, and it has. I don't have a benchy here. I think no. But on the benchy, on the bow, on the front part, it has like this weird double shadow that kind of looks like it's an offset of the top surface. I don't know what is going on, but yeah, if you have those holes in the front, just go down a centimeter or so from that, and there's going to be a weird kind of shadow rim
But
edge.
this is totally normal. I actually wanted to make a video about that.
No, it is way different between slices. So
it is way
Flickr,
different
Cura,
between
and
slices, but I think it's, well, in my opinion, it's coming due to thermal contraction of the material, because this is exactly the point where like the deck of the benchy ends, and this deck will contract more than the layers that are above that, and for this reason you can see this this bow in there, or this double shadow.
Yes, but that's a different area than what I mean with Kiss Slicer.
Okay.
I'm going to send you a photo later.
Oh yeah, perfect.
Because again, that there is specific things where some slicers just kind of do weird things that others don't, and if you have a print that kind of doesn't come out the perfect way you think, here, I might even have a photo here. Sorry, old people Googling. It's not something you want to do on a podcast. But yeah, if you see weird stuff in your print that you can't explain, maybe just try a different slicer. It's, you know, it's free. At least 80% of them. Try different slicers. Try different slicers that they're pretty easy to set up, and see which one works for your print specifically, for your application, that sort of thing.
Yeah, that's what I also think. The interesting thing is, so I was at Formnext, and I have been talking to lots of like professional FDM 3D printer manufacturers, and more or less every one of them uses Simplify 3D. That's really, well, it's interesting because it's a commercial product and they tune everything into work in there. But I was asking myself why they're using it and why they're not using open source software.
It might have to do something with just liability, because you have a commercial supplier. But it might also be connected to the fact that, like, Slick 3R, at least the Prusa edition, is obviously Prusa. Cura is Ultimaker and has Ultimaker branding all over it, and that's kind of the software you would want to use probably the most if you have a professional setup. I know BCN 3D are supplying us custom Cura 2 or Cura 3 version for their machines. And it's just, you know, if you have Simplify 3D, you buy the license, you add your profile, and it doesn't have any weird branding in it that you wouldn't want to have in there. If you're doing something like BCN 3D, they've completely reskinned and reworked Cura to be BCN 3D Cura and not Ultimaker Cura. And that's just development effort, right? So I guess the cleanest and simplest and easiest, if not, well, maybe not the cheapest version, would be just to get a Simplify 3D license, ship it with your printer, and I bet they're not paying the full $150 for a license if they're shipping it with printers.
Well, if you pay like $50,000 for a printer, the $150 for Simplify 3D wouldn't be an issue.
True.
Yeah.
True. It's just, you know, it's a commercial product with a commercial printer. It kind of fits, but it's not necessarily, at least I think, necessary to have that commercial software in there.
Yeah, definitely. All right. Yeah, but yeah, maybe I think we have concluded everything on, well, not everything, but lots of things on that topic. Yeah, if you guys have any more questions, just let us know.
On Simplify 3D enough, I think.
Yeah. I would really like to use that software again more in the future, but I'm just really pissed off that they are not updating their software, releasing updates that just don't work, and licensing issues, what Joel has also already been talking
where
about.
people can't download profiles.
I just want to stop bashing at the moment.
Are they running out of money? Is it because they don't have a subscription model and we're selling licenses and now people have the licenses and want to keep using it?
Yeah, I don't know. If Simplify 3D is listening, let us know.
Well,
we might have pity.
Yeah, but it's probably not going to change anything. It's like, yeah, sorry, we're kind of short on cash. But yeah, let's conclude that and move on to questions. We've got 2 more questions. We've got the hour 4, but let's just keep on going. Let's at least answer one.
Yep.
So Clement CKW on YouTube is asking, why does the Infinite Z belt printer have to have a skewed axis? So we were talking about those in the last episode, where you have a belt, and then you have your Z axis essentially slanted 45 degrees. He's saying, just thinking about it, why can't it be like the normal i3 printer with a belt and the Y axis and have ending G-code to move the finished print off? So 3 things to that.
Yeah, I was thinking about that, but it currently just breaks my brain. So maybe you can give it a try and answer that question at the moment. And okay. I might add something.
Okay.
It's already late.
Number 1, patents. Stratasys. Is it Stratasys? MakerBot? They got bought by Stratasys, right?
Stratasys,
3D Systems? Stratasys, yes. Stratasys. The MakerBot Thingomatic holds the patent for having a conveyor belt 3D printer with a perpendicular Z-axis. So the idea of printing something onto a conveyor belt and then moving that off and ejecting it to the front, that is exclusive to Stratasys and MakerBot, and nobody else can use it. Full stop. Like, that is the most obvious reason why nobody else is building a printer that has a regular XYZ setup and a conveyor belt. Number 1.
Question answered.
Number 2, you can print theoretically infinitely long parts on a slanted Z-axis setup. So you can keep conveying your belt off to the side and theoretically print like a Zweihänder on a printer like that. That's kind of feeding out onto an outfeed table and only partially still attached to your printer, because it's still moving up in its virtual Z direction. Right?
It's totally breaking my brain at the moment. I don't know why. I'm thinking
it's getting late. It's 9:30 here.
Yeah. That's usually bad time for me. Nah. I think there are some problems if you want to really print perpendicular in a lying direction. It works if you would use a normal printer and just tilt it, but then the part is basically mounted to the Z-axis. But you just can't print into free air, and this might be something which is not possible with the 90-degree axis, and might be an advantage if you have this 45-degree skewed axis, but I might totally be wrong there.
Well, for infinitely long parts, your problem is going to be you can't like rewind the print an infinite amount.
Mm-hmm.
Your Y-axis basically is limited by the length of the belt.
Yeah.
So you would always have to go back and forth on that belt. With a slanted axis, you basically just advance the belt a tiny bit when you have a new layer. So you can just keep advancing that belt and your part's going to pop off at the front. And you just keep printing, advance it a bit, keep printing one layer and advance it a bit, because you're
But why couldn't you do that with a 90 degrees axis?
With a 90 degrees? Because, which way would your hotend be pointing? Towards the outfeed direction of the belt?
Yes, exactly.
How would you get bed adhesion on that?
Yeah, this is the problem that is currently killing my brain.
Exactly.
If that would even be possible in theory.
Possibly, yeah. Gravity is going to help you with that, I think.
Yeah.
But you'd need to have like you'd probably need to angle your hotend as well, because with the slanted printers, your hotend is also angled 45 degrees. So against the bed, it's actually not flattening it down. It's actually just kind of sideways squeezing it onto. That was reason number 2, because print length, and I actually forgot number 3. It is late
Well,
in Bavaria as well. Yes.
well, I guess patent is one of the biggest things.
That's a killer.
Yeah, so we still need to wait like 15 more years until the patent runs out.
Roughly. And then we're going to have the next generation of 3D printers, just like with the original generation of 3D printers, right?
Yeah, definitely. And also why other technologies are getting cheaper and cheaper over the last years, and which is helping us out a lot. Yeah.
So many things broken with that, but that could be a whole nother episode. I guess let's finish with a positive note. David has commented he's using a blender for PLA parts to make fine particles for extrusion.
Yes, I'm doing that as well. Yeah.
Sweet.
I have found that this is a really nice method to just grind everything down to smaller particles consistently. Well, you don't get consistent particles, but the bigger ones are just shredded down in comparison to using the normal shredder. The thing I found that is a problem, that the blade just heats up quite fast, and if you are blending PLA, everything will melt down and just stick to the blade.
Yeah, could you blend in distilled water?
I thought about blending my material in water to help with cooling, but the thing is, I don't want to contaminate our water right here with plastic microplastic particles, plastic microparticles. But well, I thought about just pouring everything into a coffee filter afterwards. Currently working on that topic.
That should be fine enough, right?
It depends. It depends. Nano-sized particles.
PLA, sorry, if it's PLA, like organisms are going to digest that.
Yes,
I think if you've got it through your regular sewage treatment, even that should take care of the of PLA particles. If it was ABS or PETG or some other plastic, I would worry about it. But PLA, I mean, you've got not unicorns. Squirrels chewing on bird feeders that are printed on PLA because apparently it tastes sweet. I've not tried it, but yeah, it gets digested by biological organisms.
I'm not that worried with PLA, but since I also want to work on other materials, this could be a problem. And if everyone starts just blending their parts with water and putting everything in the sewers, we have all this microplastic problem again.
Yeah. Does a regular blender actually keep up with blending PLA, or is it too hard? Is it chipping the blades?
This is a really cheap a smoothie mixer, and it has its problem. I have currently purchased a more expensive 2000 watts Philips one, and this can just chew through everything. If you have seen the Blend Tech blender videos, you know that it can even blend an iPad. Yeah, it's a nice method. You can't do really huge amounts of plastic in there, but still, the way I am really planning to do it in the future is to just kind of get it to a size that it's working in the extruder, then extrude a really coarse filament in the first place, chop that down again, and then use these consistently sized pellets for the real extrusion in the end. It's a lot of work, but I think this is the only reason, the only possibility how you will be able to get really consistent filament quality, color, and diameter out of one of these cheaper 3D printers. And I've talked to at least one manufacturer at Formnext, 3DK Berlin, and he has been telling me that they were trying to really recycle parts and not just use the upcycling, so the residues which are in the extruders, and they had problems with consistent material quality, and for this reason they dumped that idea. But what they are actually doing, they buy or they are getting some like I don't know if I think they're scrap or old yogurt cups from Ehrmann, which are
All
also
right.
made from PLA
Ooh,
or some other yogurt manufacturer. And with these yogurt cups, they are producing their recycled filament. And I think this is a pretty nice idea. And it's a pretty good
that's pretty
start.
good. Yeah. I mean, I know that like the one-time use forks and spoons, like those are PLA, those are tempered PLA and coffee stirring sticks and that sort of stuff as
Mhm.
well. But I didn't know yogurt cups were being made from PLA as well.
Not all of them, but
Okay,
at least some.
probably
So
the
I've checked the yogurt
yeah,
cups which we had at home, and they were not. They were PP or something like that.
yeah. So it's probably their organic yogurt line that's being sold in the PLA cups. Who knows? Who knows? Might
Yeah.
be an extra, argument for selling this one over your conventional one.
You can even put it into your compost.
Yeah, though, have you actually tried composting stuff?
I I have been planning to do that already last year. I haven't been doing it this year, but I will be at a filament manufacturer in a couple of weeks, and they are selling like a really biodegradable material. And I want to print some samples, put them in our compost just over the winter. It's still nice and warm in there because all the
Yeah,
microbacteria are
it's
still
very
working.
alive.
And I want to know what has happened to my parts after like a couple of months in the compost.
Yeah. I mean, I can give you some anecdotal evidence here, some stories here. I've actually had some PLA parts in our compost pile for probably 1.5 or 2 years or so, and then we moved the entire pile, and I kept finding stuff. Eggshells kind of don't break down, and PLA prints apparently also do not break down at all. So it was like the octopus printed in clear PLA, and they looked good as new, but they didn't really have the strength anymore. I mean, just from sitting out in the moisture and in the heat, does change them a bit, but it's not. I mean, it's not as easily degradable as people might think.
Mm.
Clear
Yeah,
virgin PLA,
but I think nobody or none of the filament manufacturers are really claiming that PLA is
yeah, sure.
biodegradable on normal composts, but in commercial plants,
It might be just a bit of a misperception by
yeah.
people.
But also the
Misconception.
thing is we have these biodegradable plastic compost bags here in Germany, and they are even a problem for the commercial composting companies because they are not breaking down in like the 3-month time frame they have to make
All right.
everything. So yeah, I'm really interested to take a look at the other material, which is based on just another resin.
Nice. Looking forward to that.
Yeah.
And I think with that, we can sign off for today. We've covered everything. We've done an hour and 15 minutes again. We keep trying to go on an hour, but sorry, guys, it's not going to happen.
Nah.
I think we can solidly give up on that dream.
As I said, if you are not in a hurry, I always enjoy listening to longer podcasts.
Yeah.
If you are just only taking your time to listen to a podcast, maybe this is not the most suitable one, but listen to us on your next trip, holiday trip,
next road trip, commute,
house
wherever.
cleaning, adventure, or whatever. And well, you won't be upset.
Yeah, when I was still commuting to work half an hour one way every day, it was good fun. It was good entertainment to have, something that you can just listen to, relax, and have people talk about stuff that you're interested in for a while. So I'm hoping we're providing that. As always, leave your comments below. Leave your questions below. We're always eager to answer those if we still have time at the end of the episode. Subscribe on iTunes. We're working on Spotify, right?
Yes, still some legal challenges.
Yeah.
But we're getting to there.
We're getting there.
Yeah, iTunes is iTunes. Then you can just subscribe to the MP3 feed, and
yes,
should be working in most of the podcast players.
That is the Meltzone /MP3, and that should open up in your podcast app if you're opening it on your phone. And that's just going to give you the full subscription feed. So even if you're not on your favorite platform yet, that's a way that you can subscribe to this very podcast, or watch on YouTube.
All
You
right.
can subscribe there as well. All right, but that's going to be it for today. Stefan, thank you so much for your time.
Thank you for your time.
And we will see and hear you guys. Well, you guys will hear us in another 2 weeks.
All right.
Thanks for listening. Bye.
Thanks for listening. Bye.